Hello and welcome to Tech with Briley. Today we're going to continue working on our chat application with FastAPI and HTMX. I've been working with retrieval augmented generation and a local vector store called AstraDB, but I found some limitations of this with the deployment strategy I'm trying to take. So today we're going to experiment with AstraDB and we're going to implement a new retriever using the Astra Python client. So I've got a new branch here. If you'd like to check out this code, it's on GitHub. It's open source. I might rename the project, but in any case, it should be redirected. You can see the URL at the bottom of the video here. We've been using Anthropic Claude to help us prototype the application. It's been very useful. We have this vector store module that implements classes for querying vector stores. So there we have a consistent interface. Today we'll work on the AstraDB vector store. Based on the Astra docs, we should be able to search by vector or by data, like a plain text query, using this vectorize kind of operator. I do have a vectorizer enabled on the Astra configuration. I won't go into too much detail about the back end of Astra, but it's pretty convenient. I've already vectorized the data, so all we need to do today is query it. So what I'll do is just give this these details to Claude. So there's the vector search. I need to get the we have some environmental variables. Okay, it looks like it picked up on the context pretty good. Let's read through this kind of carefully. So we've installed AstraPy. I'll actually need to freeze my dependencies. Let's look at these artifacts. So here's our new vector store. This is the part that DB token and endpoint. Interesting. So it knows about how to grab the... All right, so we'll have to yeah, we'll pass in the collection, yeah, during initialization. Query container find vectorized query, limit top K, defaulting 5. Projection vectorized true, was that, yeah. And then for document results, print document. Yeah, I did need to provide that. For result and real. Oh, I got it. I got it. Collection, find, or find one could be. We don't want to find one though. It returns an async cursor. Let's just see if it works actually. So what we'll have to do, see if this is how it's supposed to work. All right, so now we are going to check the updates to chat, and we'll need to import the correct vector store. I wish I wouldn't do that. I would down my mouse over that. It's really annoying. And the collection name. Will also be an environment variable, I suppose. Cool. So yeah, just set those up, environment variables. Then we'll go back to the Astra configuration. Astra collection name, rag service. And I'll move this out here as well. Eventually the system prompt, it'll either go into an environment variable, or I have an idea about a sort of configuration format that would be at least useful for instantiating a single project and used in both the endpoint to define things like the collection name, system prompt, but also in the ingestion endpoint. I'm thinking that we could list the documents and have a script to vectorize those documents. But I haven't gotten to that step. We're taking it one step at a time. That might never happen. We might just end up hard coding the system prompt or using an environmental variable, which at least makes it configurable with a default. So nothing else really should have changed there in the chat. We've done the requirements. So now We have our debugger running. And I need to use this app.vector store. And where do we initialize? The environment variables, I suppose we'll need to parse that when we initialize the application now. I think we've done it previously in the ChatGPT client load.env, but we're going to do that. Here in main. Makes sense to do it there. Then we gotta get our import. These are all out of order. All right, so I suspect it's not going to work just on the first try. But we have a breakpoint here in the vector store to see what we're getting back, and then for each result we will check. I suppose we can just check the whole results there. So we got a breakpoint there. Query results. It's a cursor, so yeah, it's an asynchronous cursor. So we'll need to go into that. Okay, embedding service not configured for the collection. Okay. So I'll do that real quick. All right, so then I didn't follow the instructions fully on the AstraDB. It says now you navigate to the Data Explorer for a scope database and create a collection. Got it. Done. Select OpenAI from the embedding provider drop down to generate embeddings for using Astra. Hopefully they got some documentation with pictures. got the account, I did the database, so the account, got the key, go to integrations, I've enabled that, configured it, added it, add the OpenAI integration to the new collection. Click the Data Explorer, optional, use the namespace dropdown to click namespace. Otherwise, leave default key space alone. Create collection. That's unfortunate. So you can only do it when you're creating the collection. All right, so I can add more databases. I hadn't added that under the integration configuration for OpenAI, so hopefully it'll work. If we try it again. It should work now. Let's go back to that. All right. I'd like to be able to enable it for an existing collection. Just have to create it again. Takes a while. Then I'll load the data manually. Hey, what's up, Mohammed? Welcome. How are you doing today? Welcome to the stream. Are you working with any large language models? All right, I'll have to download this again. Okay. So let's vectorize the data again. Okay, so this is why I couldn't find the file. So here's the process of vectorization. We're just going to fetch this from the GitHub document directly. We're going to split it into chunks. We're going to apply OpenAI embeddings to it. Although I wanted to sort of Astra to do that. Anyway, when we query it, hopefully it'll work. And then we're going to insert it into the prompt engineering guide collection. Okay, it's a relatively short document. And I think what happened is it failed silently. Hey, EmoDraft, thanks. Welcome. How are you doing today? Are you doing any projects with large language models or generative AI? So all I need to do is actually go and I have to clean out these global variables because actually, I'll leave those alone. Hey, thanks, I appreciate it. I hope you have a good day too. So I just need to get the API endpoint here, clear that and paste it in. And then our AstraDB token actually is incorrect now. It's from the previous collection I was working with. So what I need to do is just delete that one. And this shouldn't have indicated success. It should have told me, hey, I can't connect with those credentials. Unfortunately, it didn't do that. Okay, cool. So we'll add a new one. And it's type of credential. And I will save it, but not automatically apply that. And we'll go back into our AstraDB, grab that application, and I'll try that again. It should take a little bit longer because it's got to make some API calls. Yeah, inserting the data. Now let's see. All right, so we do have some results there. Now, all of that was to configure my prompt engineering guide collection so that it would look like this basically. So I've got a couple of collections I'm working with here. And here's my prompt engineering guide. And I guess this text embedding 3 small model means that it now is integrated with OpenAI. That means I can query it by plain text instead of vector. It saves a little bit of code locally, although at this point, soon in the project, I'm going to have to start working with these vectors and actually vectorizing the data and upserting it to the database. So, but this pull request is not focused at that level currently. All right, so I think we're done with Langlo. I can close it. It's been a really nice tool, but at the same time, it's been really frustrating. It has a lot of promise, but yeah. Yeah, I'm building a chat interface. I can show you what it looks like. Let me get it running real quick for a moment. And essentially, I have some knowledge in documents. Like a lot of companies have a lot of internal documentation, or I'm part of a community, and it's kind of a long traditional community, and we have some writings that go back to the 1600s, and we want to sort of be able to chat with those writings and these documents to kind of learn more about our companies or our communities and things like that in our history. So what I'm testing is, can I take these like historical texts or any kind of document you could imagine, a journal, a novel, and can I make the data accessible to a chat interface using a large language model? So that's what I'm testing out today. And I've got to do, I'm a little bit deep in the code right now, but it did get a result, and the content did look good. All right, so let's just see, this might just work. Okay, Well, it got a result and content back. So it's essentially what it's going to do is when I ask it a question, it's going to take these documents from a collection and it's going to search for relevant answers potentially if the document collection contains texts that are similar to what I asked for. And it's going to get those out and put those in sources and feed those to the large language model along with my request. And then the large language model will have a better output than if I had just asked it for something. So we're pretty close actually here. And I just need to revise this code a little bit. Chatbot has knowledge about documented, like a textbook, and you can ask it and it will answer you based on your information you supply. That's exactly right. And that's one of our next projects we're working on. Using this technology is really good with working with any kind of texts, and we're looking at some open source textbooks, like OpenStax. OpenStax, here it is. Misspelled it. And these are what are called open access textbooks on all sorts of different subjects. And you could see one like computer science, college success. And then you can just read that text, and students might be like studying this textbook, and you could imagine there would be a little chat bot down here that's you can ask it questions about the textbook. That's kind of what our vision is, and I know it's not like unique to us, but it's something we're working towards. We're building a prototype, and maybe we could integrate it directly with this OpenStax textbooks, but we have to take it one step at a time and learn all the nuts and bolts, how these large language models work. Currently, the chat application is on my local network, but I'm trying to deploy this as a demo for our community in mainly the Western United States, who they're part of this faith group called Quakers, and we've got ongoing discernment about like the role of technology in society and our lives, and kind of how it can serve our communities, but also in what ways it's harmful or detrimental. And sort of as a proof of concept, I'm applying this idea to show how we can learn about our history and culture through these chats. And then a friend of mine and I are working on an idea to help students learn what they're studying through an interactive chat that's integrated into their chat book, textbook as mentioned, but neither of these are like deployed where you could try it yet. We'll try to have something up pretty soon, but we're working in our spare time, so it's kind of hard to get these things running. But the main thing right now, I just need to learn how to get results back from the database. So I put like all these text snippets from you could say the textbook. They're all over here. It's a textbook on how to prompt these large language models. It's called prompt engineering. It's a fancy way of just saying how to get good results out of them, how to ask them the right questions. So I took a smaller textbook, and it's like probably around 1,000 or 2,000 words. It's not really big. And I sliced it up into to 324 slices. And each one of these is like probably around 1,000 characters. And so we can search across these and get the exact ones out. So if I ask about airlines or flights or something to do with flying, our retrieval will get these. It's just a search engine. That's essentially what it is. But it can search across vast amounts of text in a very quick amount of time using vectors. That's actually our first use case. Is we were looking at anatomy and physiology. Here on OpenStax, there was this one, interestingly. We were looking at, I can't remember if this was nursing. I thought it was nursing. But yeah, definitely, if especially if it's an open textbook, we can scan the text and use it. If it's like, you know, proprietary textbook, it's a little bit harder. Yeah, it's even hard to get textbooks, you know that, how costly they are. How do I just search for anatomy? Here it is, anatomy and physiology. So this was literally our first use case. And even if you have a different textbook, for example, you're studying anatomy and physiology, you could chat with a chatbot that is enriched with anatomy and physiology knowledge from an open textbook or multiple open textbooks. So what we want to do is we want to extract this knowledge into a way that is convenient for the chatbot to use, and then students can engage with those subject-specific chatbots and help, you know, with whatever they're engaging in. Yeah, graphical diagrams. So that is a bit interesting. Right now we're mainly working with chat, so we'd have to look into more about that question. But these models are what are called multimodal, and at least they're able to take input from text, from spoken words like recorded audio, and visual input, so pictures you could upload and things like that. They can produce pictures and rudimentary diagrams, but they're not reliable or factual or anatomically correct or anything like that. The types of models that produce diagrams, and particularly the ones that do produce pictures, are called diffusion models, and they don't have a sense of anatomy or space or physiology or skeletal structure or physics. So the things that they generate, you know, have extra appendages or fingers and things like that. So we wouldn't probably be able to look at that type of use case initially, but this is why we think this is an integrated solution that would sit inside of a textbook, that the textbook can easily have these diagrams, and this is a chat companion basically to help people understand the concepts. Yeah. So we gotta, essentially what it boils down to is we have to understand what the tools are good at, what they're not good at, strengths and weaknesses, and what their potential harms are as well. And try to use them in ways that are aligned with people's goals and for tasks that they're effective at. And this text retrieval and summarization and text generation, they're really good at that. But yeah, so this is exactly the thing where we would you know, there's pictures in this book already, diagrams, so we wouldn't have to necessarily replace that. We would align with that, the OpenStax initiative, and integrate into it some more augmented generative AI. See, he's got good diagrams and everything. Pretty cool. Yeah, so we just got to take it one step at a time. But those are really great suggestions. And if you're interested in getting involved with the project, even as a non-coder, we can use all types of contributions. If you want to help us test out the textbook integration, that would be very valuable, because you know, you have a vested interest. You're learning, you're studying this subject, and you would benefit most directly from having a tool like this. And so we could get some great feedback. And this is an open source project. It's like we're publishing on GitHub. We're using open textbooks. We're trying to do things that you could actually run on your local computer even. So we did get a result back here. And essentially what I need to change, I need to take a look at the structure. So we need the content and potentially the source and similarity. If we can get those, always cite your sources. You know, that's important. And we're trying to cite the sources from which these retrieval documents came, especially if it's from multiple documents. Okay, so let's take a look at the debug output again. We're going to run it again and just look. When it hits this line, it'll just show me what's going on inside of there. So I can send another message. But yeah, if here's the book, the textbook link. Just if anything, this is a great resource. If anything you take away from this chat is check out OpenStax. They're really good initiative. Using Python language to build the app, and a little bit of HTML and CSS because it's a web application. So it's a web chat. It runs in the browser, which is another cool thing. You don't have to download anything if you're just one of the end users. And this web application format, then we're able to integrate it, for example, into that online textbook viewer on OpenStax. It's basically an HTML application as well. So that's like the long-term vision. That's like the goal, is to see if we could integrate it with like an OpenStax type project. But that's pretty far away on the horizon, if even at all feasible. We'd have to really work towards that. We have a shorter term deadline of like August, that we want to have something concrete done by August. And actually this project I'm hoping to demo tomorrow. So I'm hoping to have just this retrieval augmented chat deployed tomorrow for at this other organization I work for called Western Friend. And so this is another website where we have a lot of text documents. It's an online publication and community. And this is actually part of an article I wrote. Yeah, luckily the Python ecosystem has a lot of the lower level details taken care of. So you don't have to really think about low level details. You have like higher level abstractions that get closer to what you're thinking about. They're getting closer into the domain, the problem domain. We say, like, I'm dealing with documents. I just want to think about documents, and I don't want to think too much about syntax or things like that, or memory allocations and stuff like that. It's kind of wasteful of my brain time. And this is not a super high performance particle physics simulation or something where we would need to optimize for that, or memory safety or anything like Rust would provide. So the slowest parts of this application are actually not the Python language, but retrieving the documents over the network and getting responses from the large language model, for example, that comes over the HTTP or over the web. So we're talking in milliseconds of latencies, but there's processes running on remote computers to generate texts that take seconds, or then sending it to the user. So the slowest parts aren't actually the Python code. We're not worried about Python being fast or slow. All right, so let's just send it another message. Anyway, I wrote this article that was just published in the latest issue of Western Friend magazine about technological discernment. And as a sort of follow-up or an addendum to that article, I want to have a little demonstration of how these technologies work. So if you're interested more about like the philosophical reasoning for this project, you can check out that article. And let's get this chat running again. It's running, and we're going to test again. It's going to hit this breakpoint. I'm just going to take a look at the code again. The structure of this, so we're getting here to this yellow line, and at that point it's like stopping the engine in motion, and I can see what's going on here. So we see we have a result here, and I have that result in hand, and the content is right there. So I'll just say get, that should work. There's no document, so that's not correct. So the result, you can get the content directly from the result. Then there is some metadata. There's a source. Then the metadata has a source, and then the similarity score is on the result, right? Under $sign similarity. Okay, yeah, so it was pretty close, actually. Got Pretty close. And now our code should work if I continue it. And it's just going to iterate through those, but I might need to reload it because the first one might have been an error. So the idea is that, we want to cite our sources. So when I ask the question to the bot, it's going to give me an answer, but also it should tell me where did it get the answer from. So I know these large language models sometimes they essentially make things up. That's how they work. They actually are just always generating these outputs statistically. So every output of them is actually just made up, but they are very good at making things up. And sometimes though they make up things that sound plausible but are wrong, just like people. And they're trained on people, on knowledge of people. So there's all sorts of things that are wrong and biases and things like that that get baked into these models from all the human activities that they're trained on. So it goes both ways. But what we want to do is say, here's the information that informed this response, and then to see how relevant it is and reduce the likelihood that the response will be fabricated and incorrect, misinformation. Humans also produce misinformation, but we also produce disinformation. And I think these models don't produce disinformation, but they just can produce misinformation. So that's what we're trying to reduce. Really optimistic, because many people see that Python is very easy for beginners. It's nice you can learn beginner language like Python and HTML and be able to code something like that. Yeah, for sure. And I'm actually trying to make this project so that you don't even really need to know Python. I'm trying to, one idea for this chat project is that if you have just a few documents, like some text files that you've managed to copy and paste from a textbook or a video transcript or whatever, you can paste those into this project and just start chatting with them. There are some applications like that, but I'm trying to make this real low barrier to entry, so no coding should be necessary. I don't know if I'll actually get to that part of the picture, and there may be already some projects that are better suited for that. In fact, I can probably find one. One doesn't come to mind. I know I have seen one recently. No, I can't remember. The whole this general concept is called retrieval augmented generation. Okay, let's see if nothing is moving. Can you try refreshing the page? I don't know how I could really, if I can do anything to get it out of sync. I could stop and I could end the stream and start it again. Yeah, it's weird. Okay, let me try just ending.